Bismillahirrahmanirrahim. The next question is question number 4, part 3. We have to prove that sine theta plus pi by 6 plus cos of theta plus pi by 3 is equal to cos theta. In this question, the identities that we are going to use are sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta, because we have the expression of sine of sum of two angles. Okay, so we are going to use this identity, as well as here also we have cos of sum of two angles, so we are going to use these two identities. I'm going to take the left hand side and prove it equal to cos of theta by using these identities. Now sine theta plus pi by 6, according to this identity, in place of alpha we have theta and in place of beta I have pi by 6. So I'm going to write the right hand side of this identity by replacing alpha by theta and beta by pi by 6. And over here I'm going to do the same thing with this identity. Okay, sine alpha plus beta is, we know that sine of alpha cos of beta, okay, plus cos of alpha and sine of beta. I have applied the identity sine alpha plus beta on this and I got this, plus I'm going to write the next cos of alpha plus beta is equal to cos of alpha cos of beta minus sine alpha sine beta. So what am I going to write it? Write is cos of alpha cos of beta pi by 3, okay, plus sine minus of sine of theta and sine of beta. Okay, in place of beta we have pi by 3, in place of alpha we have theta. So you just have to write the right hand side by replacing alpha by theta and beta by pi by 3. So this is what we have done. I have applied the first identity sine alpha plus beta to this expression, and I have applied the second identity cos of alpha plus beta to this expression. This is what we got. Now next is, I'm going to simplify this expression. Sine of theta, as theta is unknown, so it will remain like this, but here we have pi by 6. Pi by 6 is 30 degrees. Okay, pi by 6 is the radian form of 30 degrees, and we know that cos of 30 is equal to cos of 30 degrees is equal to under root 3 by 2 from our previous knowledge. So it means that cos of pi by 6 will be equal to under root 3 by 2. Okay, so we are going to replace cos of pi by 6 by under root 3 by 2. Under root 3 by 2 plus cos of theta and sine of pi by 6. We know that sine of pi by 6, that is sine of 30, is equal to 1 over 2. Sine of pi by 6 is equal to 1 by 2. Replacing this by 1 by 2. Okay, this is the first bracket. Same here, we are going to replace cos of pi by 3 by its value, because we know that pi by 3 is actually 60 degrees and cos of 60 degrees is equal to 1 by 2. Okay, and sine of 60 degrees is equal to under root 3 by 2. So repeating the same knowledge of cosine of pi by 3, cosine pi by 3 is the radian form of 60 degrees. Okay, so cos of 60, we know that cos of 60 is equal to 1 by 2 and minus sine of theta, and sine of pi by 3 is under root 3 by 2, because pi by 3 is the radian form of 60 degrees and we know that sine 60 degrees is equal to under root 3 by 2. Okay, so now simplify this expression. We will open the brackets. Sine theta plus half cos theta, over here we will have half cos theta and minus under root 3 by 2 into sine theta. Okay, we can write sine theta into under root 3 by 2. We can write it as under root 3 by 2 into sine theta, and same here. Okay, because commutative law holds in the set of real numbers. Now as the denominator is same, Now let me cancel out these two because they are the same expressions with different signs. So the only thing remaining is half of cos theta plus half of cos theta, which will be equal to, if I take cos of theta common from it, half plus half will be equal to 1, and cos theta into 1 will be equal to cos of theta. This will be equal to cos theta, and which is equal to the right hand side. Okay, and this completes the solution of this question. We have proved that sin theta plus pi by 2 by using these two identities. I have applied the first identity to this expression, second identity to this, and then after putting the values of sin pi by 6, cos pi by 3, sin pi by 3 and cos pi by 6, we got this expression. This expression was cancelled out by the same expression over here, and half cos theta plus half theta makes 1 times cos theta, which is equal to the right hand side, and this is what we had to prove. So this completes the proof of this expression. Now in this expression we have to prove that sin theta minus cos theta into tangent theta by 2 over cos theta plus sin theta into tan theta by 2, this whole expression is equal to tangent theta by 2. Okay, for this I am going to take the left hand side, sin theta minus cos of theta tan theta by 2 over cos of theta plus sin theta tangent of theta by 2. Over here I am going to write tan theta by 2 as sin theta by 2 over cos theta by 2. Sin of theta minus cos theta, sin tan theta will be sin of theta by 2 over cos of theta by 2 over cos of theta plus sin of theta. Again I am going to write this tangent theta by 2 as sin theta by 2 over cos theta by 2. Now taking the LCM over here, what do we have? Cos of theta by 2 sin theta minus cos of theta and sin theta by 2. Okay, taking the LCM, in the denominator we will going to have cos of theta by 2 over, again taking the LCM over here, cos theta by 2 will be multiplied with cos of theta sin theta and sin theta by 2. This is the denominator, and in the denominator of it we have cos theta by 2. These two are going to be cancelled out. You can cancel out these two. Okay, so we will be left with this expression only, cos of theta by 2 sin of theta minus cos of theta sin of theta by 2 over cos theta cos of theta by 2 plus sin theta sin of theta by 2. Now we know that this is a cos identity, cos of alpha minus beta, and if you look at this, this resembles the identity sin of alpha minus beta, because sin of, using this identities, sin of alpha minus beta is equal to sin alpha cos beta minus cos alpha sin beta. Okay, and cos of alpha minus beta is equal to cos alpha cos beta plus sin alpha and sin beta. Okay, if you observe these identities, the right hand side of this identity resembles this. Okay, over here we have, in place of theta we have, in place of alpha we have used theta. So this, if you take this as alpha and this is beta, so this is cos of beta, okay, into sin of alpha, this expression is over here, minus cos of alpha. Alpha was theta, so this is cos of alpha, okay, into sin of beta. So if you compare these two expression, alpha is theta and beta is theta by 2. If you compare this expression is equal to sine alpha minus beta, so this expression will be equal to sine alpha minus beta. Okay, I am going to write the expression in the denominator as sine. In place of alpha over here we have used theta, sine alpha cos beta, okay, and cos alpha, okay, sine beta. If you compare both these sides, in place of theta we have used alpha. If you replace alpha by theta and beta by theta by 2, we are going to get this expression. Okay, so it means this expression should be equal to sine of alpha minus beta. What is the alpha used over here? Theta minus theta by 2 over, similarly comparing the expression in the denominator with this expression, the right hand side of this expression is the same as this. Instead of alpha, we have, if we take theta to be equal to alpha and beta to be theta by 2 and replace alpha and beta by theta and theta by 2, we are going to get this expression. It means that this expression according to this identity should be equal to cos of alpha minus beta. In place of alpha we have used theta and in place of beta we have used theta by 2. Okay, similarly so in place of here, if I replace theta by alpha and theta by 2 by beta, we are going to get the same expression as this. So this expression will be equal to cos of alpha minus beta, alpha minus beta. Okay, and this is equal to theta minus theta by 2 will be equal to theta by 2. So sine of theta by 2 over cos of theta minus theta by 2. By taking the LCM, this is going to be 2 theta minus theta, which is equal to theta. So we are going to get tangent theta by 2, which is equal to the right hand side. So this completes the proof of the given identity. So we have taken this side by using the identities right to left. On this expression, first we wrote tan theta by 2 as sin theta by 2 or cos theta by 2. We took the LCM. After taking the LCM, we got the expression which were resembling these two. So I have replaced the left hand side of this identity, and from where we got the required result. Now in this question we have to prove that this whole expression is equal to cos of theta plus phi over cos of theta minus phi. Okay, so taking the left hand side, 1 minus tangent theta, tangent phi over 1 plus tangent theta and tangent of phi. Now in order to bring cos, obviously we have to write this tangent into sine over cos and tangent phi into sine phi over cos phi. Okay, so 1 minus tangent theta is equal to sine theta over cos theta, and tangent phi is sine of phi over cos of phi over, in the denominator we are going to repeat the same thing. I will going to write tan theta as sine theta over cos theta and tangent phi as sine phi over cos of phi. Now taking the LCM of both the sides, this is 1 over 1. This will be the LCM which we multiply to the numerator over here. So taking the LCM in the numerator as well as in the denominator, we are going to get cos of theta cos of phi minus sine theta sine of phi. Okay, and let me write it here. I don't have enough space for the denominator. Taking the LCM, cos of theta into cos of phi minus sine of theta cos of theta into sine of phi over, in the denominator we will have cos of theta and cos of phi. Similarly, taking the LCM over here, we will have cos of theta, cos of phi plus sin theta, sin of phi over cos theta and cos of phi. Now as the two expressions are same, they will be cancelled out and we will have the expression in the numerator over denominator. This will be equal to cos of theta cos of phi minus sin of theta sin of phi over cos of theta cos of phi plus sin of theta over sin of phi. Now if you look at the identity cos of alpha plus beta, this is equal to cos of alpha cos of beta minus sin alpha sin beta, and cos of alpha minus beta is equal to cos of alpha cos of beta plus sin alpha sin beta. Okay, now if you look at the expression in the numerator, this is the same as this expression. Okay, instead of alpha we have theta, and if you place beta by 5 we are going to get the same expression. It means that this right hand side is equal to cos of alpha plus beta. So this is actually the identity of cos of alpha plus beta. In place of alpha we have theta, and in place of beta we have phi. So in the numerator, this whole expression according to this identity will be equal to cos of theta plus phi, okay, cos of theta plus phi, and in the numerator if you look closely, this right hand side is equal to this expression. If we replace theta by alpha and phi by beta, we are going to get this expression. So if this expression is equal to cos of alpha minus beta, so over here in place of alpha we have theta, in place of phi we have beta. So we are going to be we can write this as theta minus phi, okay, and it is the expression on the right hand side, and this completes the proof. Okay, this is a cos of theta plus phi over cos of theta minus phi. So we got this expression, and this completes the solution of this equation. We have just used these two identities. First we have used sin theta, we have converted all tangent into sine over cos, and after taking the LCM the denominator is cancelled out, and after this we got the expression on the right hand side, which we have replaced by the expressions on the left hand side to get the required result. Now the next question is question number 5. In this we have to prove that cos of alpha plus beta cos of alpha minus beta is equal to cos square alpha minus sin square beta, and also this expression is equal to cos square beta minus sin square beta. Okay, so first I am going to convert this expression into this form, and then from this form we can easily find this expression. So I will start from here, will make it equal to this expression, and this will make, and then I will make this expression equal to this expression. So it will prove the the whole result. Okay, so starting from here, cos of alpha plus beta and cos of alpha minus beta. Writing now cos of alpha plus beta, its expression is by using the identity cos alpha plus beta. We know that this is equal to cos alpha cos beta minus sin alpha sin beta. Okay, and cos alpha minus beta is cos alpha cos beta plus sin alpha and sin beta. Now we have to multiply. I have written cos alpha plus beta. I have replaced it by the identity cos alpha plus beta equals to the right hand side, and the cos alpha minus beta by the right hand side of the identity cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. So expanding these, and now I am going to multiply both these brackets. First of all, cos alpha cos beta will be multiplied with cos alpha cos beta, which will give us cos square alpha cos square beta, and then multiplying this with this expression, we are going to get plus cos alpha cos beta into sin alpha sin beta. Okay, I have multiplied this expression. Similarly, multiplying these two, now I am going to pick this and multiply. Just we are doing the bracket multiplication. Okay, multiplying these two, we are going to get minus sin alpha sin beta cos alpha cos beta, and multiplying these two we are going to get minus sin alpha into sin alpha will be sin square alpha, and sin beta into sin beta, sin beta into sin beta will be sin square beta. Okay, if you see, these two expressions are exactly same but having the opposite sign, so we are going to cancel out this whole expression with this. Okay, so we will be left with these two only, cos square alpha cos square beta minus sin square alpha and sin square beta. Now from this expression we have to get this expression. Okay, over here alpha is with cos only and beta is with sin only. So what am I going to write? We want alpha with cos only, so sin alpha I'm going to replace it by 1 minus cos square alpha, because the expression that we need to prove here is alpha is with cos and beta is with sin. So I'm going to replace sin alpha in the form of cos alpha, and I'm going to express cos square beta in the form of sin of beta. Okay, so for that I am going to use the identity. The first identity that we learned in trigonometry was that using the identity we know that cos square theta plus sin square theta is equal to 1. So using this identity we know that sin cos square beta will be equal to 1 minus sin square beta. So from here this is equal to cos square alpha, and you know that beta we want with sin only, so I'm going to write this as 1 minus sin square beta using this identity. Okay, and minus, we know we want alpha with cos only, so I'm going to write sin square alpha as 1 minus cos square alpha into sin square beta. Okay, and then multiplying these brackets, cos square alpha minus cos square alpha sin square beta, and again multiplying this and with the negative sign, so this will be sin square alpha sin square beta minus minus sin square beta. Okay, and over here we will have plus sin square beta into cos square alpha. Now what do we have here? If you look at these two expressions, these are same expression with opposite sign, so it will be cancelled out and we are going to get the expression that we require, cos square alpha minus sin square beta. Okay, so this is the first expression that they wanted us to prove. That is what I have proved. Now we have to prove that this expression is equal to this. Now we have alpha with cos and beta with sin. Over here we have beta with cos and alpha with sin. It means that we want sin alpha and cos betas. Okay, we don't want cos alphas, we want sin alpha. So again I'm going to use this identity and I'm going to write cos square alpha as 1 minus sin square alpha. Okay, so I'm going to start from here. From here cos square alpha can be written as 1 minus sin square alpha, because now I'm proving this and here we need sin alpha, and cos beta. So I am going to change this expression, write it as 1 minus cos square beta. Now this will be equal to sin square alpha minus 1 plus cos square beta. Okay, opening this bracket. Now plus 1 and minus 1 will be cancelled out and we will be left with cos square beta minus sin square, cos square beta minus sin square alpha. And if you look at this expression, both these expressions are same. So from 1 and 2 it is proved that this I had started from this expression. Okay, and I converted it to this form, which proves the first result over here. Then I took this expression and after working on it we got this expression 2 in expression 2, and this completes the question. Now in this question we have to prove that this whole expression is equal to tangent alpha. For that we are going to open these brackets. I will write sin alpha plus beta as the sine and cosines of alpha and beta as we did in the identities. So first using the identity sine of alpha plus beta, which we know is equal to sine alpha plus beta is equal to sine alpha cos of beta, okay, plus cos alpha and sin of beta, okay, plus we know that sin alpha minus beta is equal to sin alpha cos of beta minus cos alpha sin of beta over again cos of alpha plus beta. After using the identity, this is equal to cos of alpha and cos of beta minus sin alpha sin beta, okay, cos alpha cos beta minus sin alpha equals cos of alpha plus beta is equal to this expression, plus cos of alpha minus beta is equal to cos of alpha cos beta plus sin alpha sin beta. So this is what we got by opening all these brackets. Now as you may see over here, cos alpha sin beta is with a positive sign. If I open this bracket, I am going to get this expression, and over here if you open all the brackets, I remove all these brackets by simply opening them. This is the expression that we are going to get. Okay, this is what we get. After this, you may see that this expression and this expression are same, having opposite side. This, so these will be cancelled out. We will be having these two expression also, and they are the same also. Sin alpha cos beta plus sin alpha cos beta will be twice of sin alpha and cos beta. Over here, the expression that can be cancelled out are these two. So we will be left with 2 times sin alpha cos beta, twice of this expression, okay. And similarly over here we have the same expression, so we will be having twice of cos of alpha and cos of beta. Now as you may see, 2 can be cancelled out with 2, cos alpha will be cancelled out with cos beta, cos beta will be cancelled out with cos beta, and the only expression that is remaining is sin alpha over cos alpha, which is equal to cos alpha, and this can be written as tangent alpha, which is equal to the right hand side. So this completes the proof of the given identity, okay.